Hello everyone, let's start with the next topic, EMF series. Then EMF means the unknown half cell potential is measured with respect to standard hydrogen electrode, then obtained cell potential is known as EMF of the unknown half cell. If we have a number of elements and we measure their potential with respect to standard hydrogen electrode and arrange their either oxidation potential or reduction potential in their ascending order or descending order, then obtained series is known as EMF series or electrochemical series. Last time, EM series or electrochemical series, when unknown half cell potential is measured with respect to standard hydrogen electrode, then obtained potential of the cell is known as the EMF of the cell. If we have a number of elements and we measure their potential with respect to standard hydrogen electrode and their oxidation potential or reduction potential are arranged in their ascending order or descending order, then obtained series is known as EMF series or electrochemical series. Generally, this EMF series are written in form of reduction potential and that one also in a descending order. Generally, right? According to present IUPAC convention. Okay, now just give attention. EMF series or electrochemical series. So as we discussed, when unknown half cell potential is measured with respect to standard hydrogen electrode, then the obtained cell potential is known as EMF of the cell if potential of elements are measured with respect to SHE and the oxidation potential or reduction potential are arranged in their ascending order or descending order, then obtained series is known as EMF series or electrochemical series. Here I am giving you electrochemical series in form of reduction according to the present IUPAC convention. Okay, just go through it. Even in a textbook they gave electrochemical series. Just see it and then continue with this topic. Here I am giving you some example of the EMF of the cell and I am arranging their reduction potential in descending order. Here I wrote the sum potential, reduction potential, and I arranged them there in a descending order. Now just give attention. See, in an exam, if you write out this one, it's okay. If you don't write down, then it is also okay. Okay, but from my side, I always insist the students write down few example out of them. Clear? And always mention the direction. That here I am mentioning top to bottom. Right? So because to write the characteristic of the EMF series, this one is very important. Now just give attention. as we observe in this given reduction descending order of EMF series, when we move from top to bottom in EMF series, the potential value, reduction potential values are decreases. Okay, so this one is the first point of the characteristics. You have to write in a statement only. Don't put a sign, please. Reduction value is decreases. That means value of reduction decreases. That means their tendency to experience the reduction decreases. That in redox reaction, which is experience the reduction, it helps to oxidize the agent. That means the intensity of the oxidizing agent is also decreases. Clear? What happened? Top to bottom reduction potential decrease. That means to experience the reduction reaction tendency decrease. To work as oxidizing agent tendency decrease. Reduction matlab to gain electron. That means the tendency to gain electron decrease. Clear? Once again, top to bottom reduction potential decrease. To experience the reduction reaction tendency decrease. To work as a oxidizing agent tendency decrease. To gain the electron tendency decrease. Clear? So reduction potential decrease, tendency to gain electron decreases, strength of oxidizing agent decreases, intensity to experience the reduction reaction decreases. Second point, that means which things are increasing with decreasing of reduction potential. Then tendency to gain electron decrease. That means with top to bottom E0 reduction decrease. Then with respect to this, in a first case we wrote tendency to gain electron decrease. So here tendency to lose electron increase. Same way, the strength of the oxidizing agent decreases. That means the strength of the reducing agent increases. Intensity to experience the reduction reaction decreases. That means intensity to experience the oxidation increases. Third, by this one, if you know the EMF series, EMF value, at least you can predict which half cell is work as anode and which one is work as cathode when we connect to two half cell. Now just give attention. In a galvanic cycle, we know that the zinc is work as anode and copper is work as cathode. Now just give attention. Zinc and copper, which have a higher potential? Copper, what is the value? 0.34 volt. Which potential is this? Reduction. That means the half cell which have a higher reduction potential, it work as cathode and the other is work as anode. Once again, we have two half cells, zinc and copper. In a galvanic cell, we know that the zinc work as anode, copper is work as cathode. Clear? Why it is work as cathode? Right? Then in the EMF series, the copper potential, which potential? Reduction potential is higher than the zinc. That means copper have a higher tendency to experience the reduction. That means copper is work as cathode, zinc is work as anode. In short, we can say that the half cell which have a higher reduction potential, it work as cathode and other is work as anode. Suppose the series is in given form of oxidation, then opposite one, the half cell which have a higher oxidation potential, it work as anode and other one is work as cathode. Clear? So third point, we can predict the anode and cathode. In general, the reduction potential of cathode, if we have two half cells, the one is reduction potential is higher than the other one, then which have a higher potential, its work as cathode and other one work as anode. Same way, if we have an oxidation potential, then if we compare oxidation potential of one half cell and if we found that is more than the second one, then first half cell which have a higher oxidation occur at anode, that means this is work as anode and this one is work as cathode. Fourth, we can calculate the E0 cell. If we know anode and cathode, right, then E0 cell is equal to what? E0 oxidation of anode minus oxidation of cathode, or E0 reduction of cathode minus E0 reduction of anode. So we can predict the E0 cell. This E0 cell is a theoretical value, it is not a practical value. Practical value that is measured by the galvanometer, and to measure its accurate value we have to use the potentiometer. Clear? Okay, once again, to measure the accurate value of the cell potential we have to use the potentiometer. Okay, clear? Right on.